We are going to create this prototype. Birds. Thank you for clicking on the video. In today's tutorial, I'm gonna teach you all about the LimboAI Behavior Tree for Godot 4. Together with the state machine, the behavior tree is my absolute favorite thing that I've learned in the past 6 months since I started game development. Which, by the way, the state machine video did incredibly well. We've got like 100,000 views, which is insane. And apart from all the positive feedback, there was also quite some feedback that the state machine isn't necessarily the first thing that you should learn. Some stated that you might be better off learning to code and program first, which is a valid point. And honestly, I had no idea what I was talking about. I barely started game development. It was just a clickbaity title. I'm sorry. So I'm not going to tell you what to learn first anymore. Let's start from a clean slate. In this video, I'm going to tell you what the second thing is, what you should learn as a Godot beginner. The behavior tree. Let's get into it. As explained in the previous video, the state machine helps you managing all the states of your character, like crouch, jump, attack, and so on. The behavior tree is a way to give other characters in your game a form of intelligence, you know, that they can roam around the world, they can chase you, they can attack you. It's basically the AI for all your non-playable characters in your game. And while I was kind of joking that the behavior tree is the second thing you should learn, I wasn't too wrong, because with the state machine, you have your own character roaming around in the world based on your controls, and with the behavior tree, you have your enemy NPCs that, you know, you can interact with. So with those two combined, you basically have, you know, the essentials, the fundament of your game. So yeah, it is the second thing you should learn. So, what is a behavior tree in video games? A behavior in a video game is a way to tell a character or enemy what to do. For example, an enemy might patrol an area, chase a player, or run away when hurt. These actions are behaviors. Instead of writing one big complicated script to control a character, we break behaviors into smaller rules that decide what the character should do at any moment. In the LimboAI Behavior Tree, tasks are executed from top to bottom, following the order in which they are placed. However, the way these actions behave depends on whether they are inside a selector or a sequence. And those are the most important when you first start, selectors and sequences. Sequences ensure that actions happen in a specific order. If any task fails, the entire sequence stops immediately, and the remaining tasks are not executed. But with selectors, as soon as one action succeeds, the selector stops and ignores the rest. And don't you worry if you are anything like me and you still don't understand a word that I just said, because in a minute or two we're gonna start with the actual project and I'm just going to show you how it works with an actual game. But one thing that kind of helped me, and maybe helps you too, is the moment I started seeing the sequences as a to-do list, and I started seeing the selector as a container that selects just one task that succeeds. If it doesn't succeed, it goes to a backup. So I see it as a list of backup actions. We are going to create this prototype. Birds. Lots of birds. Blackbirds more particularly. Oh, one just died. Birds that roam around a platform. They go towards the camera, away from you, left, right. They can peck the ground multiple times. They can also tweet. While there's no sound, you can see a little tweet animation. And when you get closer, they will fly away somewhat randomly. Whee! I'm going to share you the download of the sprite in the description of this video if you want to, you know, one-on-one recreate this prototype. So let's start by creating a new project. The next thing that we're going to do is to install LimboAI for your version of Godot. In this case, it's 4.3, but let's say 4.4 is released. You're going to pick the 4.4 version and select download. Then click install. You're going to get a bunch of errors. Just ignore them. Nothing's breaking. LimboAI has been installed successfully. If you're completely new to behavior trees, then this is super overwhelming. I get it. What really helped me is the demo folder. Go to the demo folder, click on scenes, and there is this showcase scene right over here. Double click on it and click on the start current scene. And this is super helpful because on the right side, you see the main sequence that holds different sequences like pause before action, pursue player, and melee attack. And you can literally see what it does and in which order. So I suggest that you click on the begin tutorial right over here. And it basically explains what I just explained, probably in a better way. And you can also see the behavior together with the actual behavior tree. Super helpful. All right, enough boring explanations. Let's make a prototype. And don't you worry if you still don't know how the behavior tree works, because I'm going to repeat lots of explanations during this bit of the video. We're going to create the main scene. I'm going to go through this pretty fast. We're just going to call this one scenes. For this tutorial, I'm just going to create a scene here called main. And in the scene, we're going to create a simple mesh instance 3D. And we're going to give it a, let's just give it a box shape. Why not? With the dimensions of 50, 1.10, it doesn't really matter. We need a platform. And I just got a tip from Logi to add collisions way easier by just clicking on mesh when you've got the mesh selected right over here, and then click on create collision shape. And I think you can just call it a static body child and single convex. And now we have ourselves a collision shape that's exactly at the same shape and size as the mesh. Let's also add a player to the scene by adding a folder to scenes called agents, or whatever name you want to call it, and add a new scene, a 3D scene in the agent scene called player, and we're going to extend it from the character body 3D node. Let's add a simple mesh instance 3D to it. The good old pill shape yet again. For this example, give it a radius of 0.2, 0.75, and that's about it. The player needs some collisions, so click on plus, search for collision shape 3D, make sure to select the pill shape yet again, and put the radius to the same amount. I think it was 0.2 and the height was 0.75. And here you go, you've got yourself a pill-shaped character with a collision. And now that I think of it, I could have probably also used the shortcut. Last but not least, let's add a camera by searching for camera 3D, put it a bit in front of the character. Let's add some basic movement logic by clicking on the main node of your player scene, click on plus, make sure to check this basic movement template, and we're going to put the script file in the folder that we haven't created yet. We're just going to call it scripts, and for this tutorial, let's just call it agents, and yeah, here we go. And with that, we should have a playable character. Go back to the main scene, drag and drop the player object in it. Let's test out the scene. It works, but it's kind of dark, so let's add the environmental lighting. Yeah, it's fine. It doesn't really matter for the tutorial, obviously. We've got a platform with a movable player. Let's get on to the good part, the birdos. Make sure to download the marvelous sprite sheet of the bird, and we're gonna add it in a folder called assets, and then let's go for textures. And in the textures folder, you can drag and drop the bird's PNG. Let's go to scenes, agents, and within the agents folder, we're gonna add a new scene called bird. We're also going to extend it from character body 3D. Yes, amazing. Let's add a sprite 3D node to the root of the bird. Search for sprite 3D. With the sprite 3D edit, you can just drag and drop the PNG to texture in the inspector. And then you see the bird PNG right over here. The PNG looks very blurry, so make sure to have the sprite 3D selected. Go to flags and put the texture filter to nearest. Now you see all the pixels being all pretty and all. While we are here, also put the alpha cut on discard. I think it makes it so that it also can cast shadows. We obviously don't want to see all 7 of the sprite frames. So click on the texture preview right over here. Scroll down a bit to animation. And here we're going to put the vertical and horizontal rows. So just put 3 and 3. And now we've got ourselves a pretty little birdo. The bird needs collision. Click on the main node, click on plus, search for collision shape 3D. And here we're going to add the pill shape too. It's a bit too big, obviously. But now the bird's got some collision too. You can barely see it with the bright background, but there's a collision right over here. And now I'm going to speed run through the animation player part because we want to animate the sprite so we can test out the behavior tree. Add a animation player to the root of the birdo. Click on animation. We're going to add the idle animation first. This one. Click on the sprite and just click on the little plus with the key right over here. This makes it so that it will add the current frame to the idle animation. And while we are here, scroll down to the transform category and click on the plus as well, because we are about to animate the bird a bit for the movement animation. And I want to make sure that in the idle animation, it stays exactly on this spot. There's probably a better way to do this kind of stuff, but I haven't figured that out yet. Let's create a new one called move. I want to end with the same position as well. And in the middle, I'm going to just slightly put the sprite upwards. And if you put it on a loop right over here, you can see the movement animation. Let's add another one called pack. That's how it's called, right? When a bird packs. I'm pretty sure it's called pack. Let's give it a duration of .75. And now we're gonna add the same position. And the pack animation is on the very first row, so we can just press the button right over here. That looks about right. Let's just duplicate these a bit. Let's add the tweet animation. Tweet. Finally, we're going to add fly. Let's match the duration, put it on a loop, and press play. All right, so we are finally done with the preparations. The first thing that we're going to do is add a behavior tree to the bird scene. Click on the main node, click on plus, and search for BT Player. It's a player of behavior tree resources. And now let's assign a behavior tree to the node by clicking on new behavior tree and click on save. And we're going to save the behavior tree in a folder called AI. And the next folder is going to be trees. And we're going to click OK. Or at least we're going to call it bird. Give it a name that makes sense. And while we are here, we might as well add a folder called tasks that also should be put in the AI folder. So whenever you want to open the behavior tree of the bird, just double click on the bird behavior tree file, and then you will see this window. And this is where we are going to build your very first behavior tree. As you can see, here's the sequence and the selector that I mentioned earlier. There are a bunch of decorators that will come in handy the moment you get a bit more familiar with the concept. Lots of built-in tasks that you can use from the LimboAI plugin. And obviously, our own code is going to be here too the moment we create it. Before adding selectors or sequencer or anything at all, you should have a rough idea about the AI that you have in mind. In this case, I already did that for you. So we're going to start with a selector. The selector will be the main node of the bird. And within the selector, we're going to add a sequence. And let's just rename this sequence real quick to sequence fly away. And we are also going to add a selector called patrol. And like I explained earlier, this selector, in this case the main composite of the bird's behavior tree, will only continue to run the childs until one succeeds. So let's say the fly away always succeeds, then it will never get to patrol. So yeah, the selector is very picky, only loves the most successful child, which is definitely not a trauma. And since we are going to figure out the flying at the very end of the video, we're just gonna put a failed task in the fly sequence. So this sequence will basically always fail instantly, and then it will continue to the next child. Because this is a selector, it will check this sequence, it fails, and then it will go to the next child who might succeed. And to see this in action, we're gonna put a wait task here. We're going to set it to 3 seconds. And now we're going to add another task in the patrol called the console print. And we're just going to print something. Print something. If you accidentally add this action within an action, it can give you an error. Just drag and drop it to the parent node, so it's a sibling of the other tasks. And you can also drag and drop it to change the order, or use Control and the arrow keys to change order. So in this case, we have a selector that only runs one successful child, which is not the fly away sequence because it always fails. So we're going to close that for now. So it will always go through the selector patrol. So with the behavior tree completed, we're going to add the bird to the world and just drag and drop it. And it's a super tiny bird. Let's change that real quick. Go to the bird scene, go to scale right over here and just put 5. Make sure to also enlarge the collision a bit. So now we should have a slightly bigger bird. I think we completely forgot to add code to the bird, so it's probably just floating in the air. Yeah, we're gonna fix that. Click on the main node of the bird, click plus yet again. Then we will put the code of the bird in the agents folder in scripts right over here. We say open, birds.gd sounds about right. Press open, make sure to have the basic movement selected. And now we have our code. Yeah, it doesn't need controls, obviously. So remove the handle jump and all the input regarding logic. So it only has the add the gravity logic right over here. We can also remove those constants. And with that, if we test the game, we have a birdo. And since the bird has a behavior tree and also some code attached to it, we can simply press play. Go to debugger and go to the debug screen that shows LimboAI. With the game playing, we can see the debug of the behavior tree. And as you can see, it never gets to the console print. It's just stuck. Like at the very top, we have a selector. In this case, the fly away sequence is always a failure. So it will always try and pick the next child in line. In this case, it's the selector patrol. This is also a picky parent. It's also a selector. And this selector has a wait node that succeeds after every 5 seconds. So after 5 seconds, this child of the selector succeeds. And then it will never get to the print. Because that is how selectors work. Whenever something succeeds in the selector, the whole selector succeeds and it goes on with the behavior tree. And there is a way to manipulate this a bit, and that's by using decorators. We can put the always fill decorator right over here and put it on top, and then put the wait node in it. What this basically does is that even though the child node of the decorator succeeds, it will still count as a fill. You can view decorators as some sort of effect that you can put on a child task. And there are many different decorators that come in handy. You can make it always succeed as well. You can add a probability decorator to it, so it only runs at a specific percentage, and many more. You can always right mouse click on one of those and open the documentation to learn more about it. In this case, let's play the game one more time and go to the debugger and see what's going on right over here. And as you can see, the print task gets this little check mark real quick after every 5 seconds. So it plays the console print as well, and then it restarts. And if you go to the output, you see that it's been printing every 5 seconds or so. And in this case, since we want both of these tasks to run, we could have probably just used a sequence, because sequences play all tasks until everything succeeds or one fails. For the example with the bird, we're going to delete it because we picked selector for a reason. We are going to add a sequence to the selector, and we're going to call it sequence chill. So again, the main selector, the picky parent, wants the sequence fly away to succeed, but it's a complete failure, so it will always continue to the next child in line. the other selector, the patrol selector. And this selector is also picky, wants the chill sequence to succeed. And we're gonna add logic to the chill sequence. Let's add a play animation task in the chill sequence. The play animation node needs a animation player reference. Normally in Godot, you can just drag and drop it. For some reason that doesn't work. You have to say new BBB node, click on it, open it, and then assign the animation player. There's probably a good reason for it, that it has to be a BB node first and then you assign the animation player. But now this node has a reference to the animation player, and I can simply type in the animation that I want to play whenever it gets to this task. So it says play animation idle. Since the chill child is a sequence, it will try and do all the tasks in it. So after the play animation idle action, we're going to add a random wait node. And we're going to wait for, let's say, at least half a second to a maximum of 1 second. First idle, then wait at a maximum of 1 second. And let's make it so after the wait action that is going to play the animation pack. We can just duplicate this action right over here and put it below the wait node, and we're gonna put pack there. So it goes idle, it waits a bit, and then packs. The thing with the play animation action is that it's instantly successful the moment it starts the animation. So there's also this handy await animation node. Let's put it right over here after the pack animation. And this node will basically wait until a given animation is completed. So we have to set that up yet again. Click on the BB node for the animation player. Select the animation player right over here. And we're going to say pack. So with that, it starts to play pack, and then it waits until the pack animation is completed. And after that, let's add another wait node for 1 second. I think if we move a little bit, it already does something. And as you can see right here with the game, besides the debugger, the picky selector will always fail its first sequence, the fly away. And therefore it gets into the patrol selector. And the patrol selector only has one sequence in it that it will try to succeed. And that goes as follows. It plays idle, it waits a bit, plays pack, waits until pack is completed, and then it waits another second. And whenever this sequence succeeds, this selector succeeds as well. And then it will start over. It's a constant loop. But we made the patrol composite a selector for a reason, because I either want the patrol selector to go and chill or walk in a random fashion. And to do that, we're going to add another sequence in the patrol selector, and we're going to call it sequence move. And for now, I'm just going to duplicate one of those and drag and drop it in the move sequence, and we're going to call the move animation. So this will play the move animation. And since the move animation is a loop, we cannot await it. So that doesn't work. So therefore, I'm just going to put a wait node. And with that, it will play the move animation at the very same spot for about 3 seconds. But maybe you already see the problem here. Since this is a selector, it will only succeed the first chill sequence, and it will never get to the move one. See, the birdo is just packing. It will wait for 1 second, and then it succeeds, and therefore the whole behavior tree gets restarted. And this is where the decorators come in handy. Click on the patrol selector and click on the probability decorator. Move it upwards a bit, right over here. And now we are going to drag and drop the whole chill sequence in the probability decorator. And the decorator is somewhat of an effect on the sequence in this case. It will only run this child at a 50% probability. If it fails, this child will return fail, and therefore the picky bastard parent will try and go to the next child in line to make it succeed. So therefore there's a 50% of our bird to chill. If it fails, it goes to the next child in line. And I do realize that I sound like a broken record, but I'm treating you guys like you've got the same dumb monkey brain as I have. And this concept just took me way too long to understand. So therefore, I'm just trying to repeat it. But maybe I'm annoying you guys because you already got it the first time. See, we played the game and the animation of the movement is very subtle. But it sometimes starts to do this little jump. And sometimes it just keeps on packing. There's a 50% chance. Let's change the move animation a little bit. Oh, and for some reason I also didn't set the frame coordination in the move animation. I'm so sloppy today. Move the sprite a little bit more. Now it's a bit more aggressive and also with the right frame coordination saved. All right, so if we play it again, it will have a more aggressive move animation. So congratulations, you've mastered the behavior tree. This is basically it. You carefully pick selectors or sequences to go through the different tasks, the different child tasks, and you can manipulate it with decorators, but also your own code. And that's the next part of this tutorial. We're gonna write a few actions to make the bird move and also fly away when you get nearby. So up until now, we've only been using the built-in actions, such as the play animation, the normal wait nodes. And with these, it's very easy to understand when they succeed or fail. But now we are going to create our own actions. And those actions will live in the tasks folder right over here. And these are going to be script files. So we're going to add the first one, and it's going to be called choose random pause.gd, and it's very important to make it extend the BT action. It's this one, which is the base class for all behavior tree actions. And be very careful to save it in the tasks folder, otherwise it won't work. And except for extending the BT action class, this code file is completely empty. And if you go back to the LimboAI view, we can also see that this one just appeared. Sometimes it doesn't get loaded in automatically, but then I just switch the views a few times and then it will pop up. Let's add the choose random position action into the move class. And let's just put it all the way up here. So every time the move sequence starts, it will first pick a position in the world to move to. We obviously have to write that ourselves. So double click on the action and it will take you directly to the script. And within a action class, you can use the tick function. The tick function is somewhat similar to the physics process function of your player character. It basically continuously runs the code. A big difference is that it should always return a status every single tick of the function. And the status that it should return is either success, failure, or running. It's super important to understand what this does. This has nothing to do with actual moving or running the character. This is whenever the action, this code, is still running. It hasn't made up its mind whether it is a failure or a success. Story of my life. And success and failure, pretty obvious. Whenever it does what it needs to do, you can return success. If it fails what it needs to do, it will return failure. In our case, it's a very simple action. We're going to remove these and we're going to add some logic here that goes about picking the random position, and then it will always return success. And you can pause the video if you want to copy the logic that I'm about to paste right over here. But it's pretty straightforward. We are storing the position variable based on the bird's position in the world. So this is just a vector 3 with all the information of the position. And then I want to shuffle the values a bit, but only the X and Z values. So it goes a bit to the left or a bit to the right, a bit towards you or a bit away from you. After that, and this is very interesting, after that we are going to store a blackboard variable, which is basically a global variable that you can use in all different tasks. So that's what we did. We manipulated the position variable and we saved it as POS in the blackboard. And after that, we return success. And this is very important because if you go to the behavior tree right over here, it only continues to the next child whenever this action returns success. because that's how a sequence works. So if you play the game, nothing really has changed since the last time, because yes, it chooses a new position, but it does nothing with it. We still have to move the character, obviously. Let's duplicate this task, this action, and call it move, and call it move to position. And let's remove this logic. So now we've got two custom actions, and if we go to the behavior tree, there's a second one that appeared in the MISC category of your behavior tree actions. And even though it doesn't really have logic, let's add it to the behavior tree, and let's put it right over here, because whenever the move sequence starts, it's going to pick a position, it's going to animate the sprite to move, and then it's going to actually move to a certain position. And we can remove the wait one, because this will only return success whenever it has reached the destination. The logic to do that doesn't exist yet, so double click on the code file, and then you go into the action code file to add the logic that is required to do those checks and also move the character. The first thing that we're going to do is to change this to running. Why? Because we want to keep on doing the tick function until the player has reached the destination. The first thing that we're going to do is we're going to create a new target variable with the same type, obviously, and we are going to retrieve the Blackboard variable the way we saved it in the previous action, because here we saved the position variable based on this vector, and here we are going to retrieve it with getVar. So now we have the target position, and I want to compare that with the bird's position by creating a new var and also setting it with the global position values of the agent. And I think I forgot to mention it a little bit earlier, but you can always access the character by simply calling agent. And now we are actually going to move the bird. And I personally like to separate such logic with the action logic. You can also do it here directly, but I also needed a reason to show you guys that you can just call different functions in the agent's code. So if we test out the game right now, it will give an error because this move function doesn't exist. So let's go to your agent's code, the bird code, right over here. And here we are going to create the move function. And I've already got it prepared. Feel free to pause the video and just copy it. It gives an error because there's no speed declared. We probably deleted it, I think, earlier on. So I'm going to add a constant right over here that goes about the speed of the bird's movement. There's also another function that doesn't exist yet. I want to flip the character whenever the X direction is like negative or positive. I'm also going to copy and paste that from my notes right over here. And this is a super simple function. It simply checks whether the X direction is negative or positive. And based on that, it will flip the sprite. And then we're getting another error. And that's because this code has no awareness of the sprite 3D node. And we can simply change that by dragging the node, then press Control and release it. And now we've got a reference to the sprite 3D as well. So to summarize, in every single tick of the move to position action, we are calling the move function in the agent's code, and the move function will move the character in the general direction of the target's position, but it will never return success here. So what I expect to happen is whenever we press play, it will move to the position and then we'll just be stuck there forever because we are not returning success here. Yeah, it kind of looks like it's doing this mating dance, you know? I think I saw a paradise bird doing that once on TV. So it's basically stuck in this loop. It reached the position, but it never returns success. So we can just add a if statement right over here. We use the distance to method to compare the current position, the X and Z values, with the target position that we retrieved from the Blackboard. And whenever it's within this little threshold, smaller or equal to 0.1, then we are going to stop the agent's velocity and we are going to return success. And by doing that, we break the loop. And by saving, we will see that whenever it moves to a certain position, it also stops moving. And by having the behavior tree right beside the game, you will see that the move to pause action keeps on running until it reaches the target position. And what's so cool about working with behavior trees is that the moment we duplicate a few birds, every bird has its own random behavior. And that's mainly because of the probability decorator and also the weight functions that has randomized values. Isn't that cool? Oh, one bird is having some problems here. It's colliding with a fellow bird, and therefore the move to action keeps on running. It never gets to its location. And now it's free. And now I start to dance, which is cool. That's a happy little accident. In this case, I'm just going to disable the layer collision, and therefore the birds will just clip through each other. All right, super awesome. We're nearly there. There's one thing that we still need to do, and that's whenever the bird gets close to the player, they fly away. And we've already set up the sequence because, again, this is a selector with the very picky parent. It only plays a successful child. In this case, the fly away always fails, and therefore it goes to patrol. But now we are going to replace this fail utility node with an actual check whether the bird is scared. So let's delete the utility action called fail, and we are going to replace it with a blackboard check called check var. So this check var action will return true whenever the variable meets a certain condition that we can set up later. But currently the variable doesn't even exist yet. So let's change that by clicking on the plus icon right over here. And we're going to say add variable. We're going to call it state. We're going to change it into a string. Press OK. And now we have created a Blackboard variable plan. We can just click on this drop down, press state. If it equals a specific value, you have to do that again by creating a new BB variant node. And here you have to define the value. It's a string, and whenever it's equal to, let's just call it scared, then this will return true. And since this is a sequence, it wants to go through all the childs as long as they return success. So we can just add a play animation action right after the check. We have to create one of those nodes, click on it, and also assign an animation player. And here we're going to set the fly animation. I'm pretty sure we called it fly. Yes. And after that, we also want to add the actual fly logic. For now, we're just going to duplicate one of the earlier actions that we created. And we're just going to call it fly away, just like this. Let's empty the tick function real quick. Let me just copy the whole fly away code and we'll go through it together. This code is pretty straightforward. We start with a variable called timer. We will set it to 0. We will define a fly duration. I figured that after 2 seconds, the bird is no longer in view. You can no longer see it. That's how long the bird should fly. There's going to be a direction variable that stores the value of the bird going to the left or going to the right. And we are going to set that into this one-time function called enter. This is only called one time compared to the tick function that's being called constantly. So only at the start, we are going to pick a random direction to the left or to the right by picking either between -1 or 1. In the tick function, we are calling the fly away scared function in the agent's code. That doesn't exist just yet. We're going to do that in just a bit. So here it starts to fly away. It's incrementing the timer that we've set up right over here. And whenever the timer reaches the fly duration constant, the 2 seconds, I'm going to make the bird delete itself from the game. And also, return success. If the timer hasn't reached the fly duration yet, it will just keep on running. So the only thing left to do is to actually add this function. Let's go to the birds code yet again. We're going to add a function called flyAwayScared. It also has the delta right over here and the direction. My own birds in my own game has a bit more logic to it. They go into this little curve and some acceleration is going on there. They also fly away in the opposite direction of where you are. But in this case, we are just going to send the birds upwards and we're going to make it go slightly to the left or to the right, depending on their random direction. But I'm pretty sure nothing is happening yet because we never set the state to scared. So if we play the game, the bird's still just gonna chill. They're super chill. To make it so that the bird gets scared, we're gonna go to the physics process function of the bird. We're gonna go just above the move and slide function, and we're gonna add this code. We're gonna check whether the player is close. If so, we're gonna set the state variable to scared, and we are going to restart the behavior tree altogether. The check if player is close function doesn't exist yet. Let me just copy and paste it real quick. There are still a few errors, and since the BT player and player are not declared yet in this scope, we're going to go to the very top of the page and we're going to add these two code lines right over here. We are adding the first node in the player group to the player variable, and we're also adding this BT player into this variable. Now we don't have any errors anymore. Let's go here and explain what this function does. Whenever the player object exists, it goes to this little code right over here. It compares the distance between the bird and also the player. And whenever it's smaller than 3, this function will return true. And in the physics process of the bird's code, we are constantly checking whether the player is close. And whenever this returns true, we will set the blackboard var state to scared. And then we restart the whole behavior tree. And it's important to know that whenever you restart a behavior tree, it does not reset the blackboard. So all the vars that you've stored will still be there. And since we've set the state variable to scared, it will restart the whole behavior tree instantly, and then it will try and do the fly away sequence. It will check whether it is scared, and then play fly, and then fly away. I think the only thing that we should do is to add the player to the group player, because I haven't done that yet. So let's go to the player scene right over here, and then we can go to node, groups. We can add a global group, and we just call it player. So now we've added the player object to the group player, and I think the code should work. If I haven't made any copy and paste mistakes, let's see. Yeah, it already worked. A few birds were spawned super close, so they were instantly scared of me. But look at that. Super cool. There's obviously way more to a behavior tree than just this little behavior tree right over here. You can go through all the different actions and just read about it in the documentation. But hopefully you've got a rough or a global idea of how sequences work, how selectors work, what you can do with decorators, how you can manipulate the blackboard vars. And that's basically the essentials. And from that moment on, you will just learn by implementing. One thing that doesn't really sit completely well with me, and I still need to figure out, is the way I restart the behavior tree in a very aggressive way whenever you get close to the player. Because ideally, you want that to happen in the actual flow. Let's say you have an action somewhere in this tree that says check if player is nearby, and then the current sequence fills and the whole behavior tree starts over. That's normally speaking the best way to go about it, to also have the player detection in your behavior tree. And the reason I implemented it on a global level in the code of the bird itself is that I want it to be able to be scared at any time and at any moment of the behavior tree. But then again, I've did some testing, and restarting the player trees in my own game isn't really performance heavy at all. So maybe this is just fine to use it that way. Anyway, my point is that there are many ways to go about the behavior tree in a creative way. And I just hope that with this video, I helped you a little bit further into your journey of a solo game developer. Leave a like and subscribe so that we can reach as many people as possible. And yeah, I see you guys around in another video or stream, all right? Bye-bye.